Not using mocks in your business logic tests will lead to a higher quality unit test. Wait, before you click away, let me explain. We write tests to ensure that our application behaves the way we expect it to. The keyword here is behave. I like to think of a unit test as testing a unit of behavior from the perspective of a client rather than testing a unit of code. Unit testing allows for verification of a single unit of behavior in isolation from other unit tests. This allows one unit test to run without causing another unit test to fail. By combining all these unit tests together, you can have a better sleep at night when you push that code to production. Before we can understand why mocking can lead to bad tests, we first need to identify what makes a good unit test. There are 4 qualities that make up a good unit test. 1. Unit tests should help protect against regression. 2. Refactoring the piece of code should not cause the test to fail. 3. It should provide fast feedback. And 4. It should be easy to maintain over time. Now that we understand what makes a good unit test, let's take a look at an example code. Here we have a simple class A that originally relies on class B and C in order to perform some calculations. In this test, we simply mock out the return values from class B and C. If you're not familiar with what a mock is, it's essentially a way to simulate a class used in testing to mimic the behavior of real dependencies, allowing you to isolate and control specific interactions. In this situation, whenever we call getValue from class B and class C, they will always return 2 and 3 respectively. The test is actually quite solid because it's simple and fast, therefore it should be easy to maintain. Okay, what's the issue with using mocks then? Let's imagine somewhere down the road you realize that it makes more sense for class B to talk directly with class C instead. So you decided to update your dependency graph to be more linear-like structure. As far as the behavior of A goes, it's completely identical. But when you run your test again, it fails. Your code refactor is indeed better and easier to follow while maintaining the exact same behavior, but why is it failing? This is because of the usage of mocks here, always defaulting the return value to 2 for class B, leading to false positives. This example illustrates how mocking can create dependencies between your test code and the real implementation details, making refactoring more challenging and potentially leading to false positives. At this point, you might be wondering, what if the dependency graph of class A is quite long? Using mocks in this situation would make testing a lot simpler since you don't need to instantiate all the inner classes during testing. While this is true that mocks will simplify the setup for this types of deeply nested graph, but if we look at the crux of the problem, this is actually the result of bad code. Why is it bad? As you continue to add more features and classes into the already deeply nested graph, changes in one part of the graph can inadvertently affect other unrelated parts. It also makes it very difficult to replace and upgrade parts of the system without affecting other components. The next question you might be asking yourself, what about API calls or database calls within your business logic? Most of the time, we make a request to retrieve some data from somewhere, we take the data, play around with it, and we send it back. When we talk about business logic, we are referencing the playing around part. If we structure our code in such a way that we separate the business logic from the API or database calls, not only will you make your code easier to understand, you avoid the need to use mocks in the first place. I would even go as far as to say, you don't even need to write unit tests for the fetching and saving data part of your codebase. These can be tested as part of the integration tests. Okay, but there's gotta be code that glues everything together. You definitely need mocks for those unit tests, no? I would argue that this piece of code is actually better as an integration test so that you can verify that the rest of your code is working in harmony. From making an API request to retrieving the data to working with the business logic and sending it back to save the data. So can I use mocks now in an integration test? Well, even with the integrations test, I would still try to avoid mocks whenever possible. The only time I would use mocks is for external or third-party services that are outside of our control. This is fine to do so because there is already a contract in place between our service and the provider. This means that we can mock the implementation details without having to worry about it changing and causing false positives. However, with things that are within our control, like databases and queues, it's better to spin up an instance to use during an integration test. With container technology like Docker, this is super easy to set up. By purposely running real instances, we can attempt to verify the behavior of our application as close to production as possible. At the end of the day, it's better to have a high quality test that ensures the behavior of our application. The closer we can get to what a user would experience, the more we can trust our codebase and have a better sleep at night. What are your thoughts? Are you a never mocker or an always mocker? Thank you for watching. David signing off. See you in the next one.